Kirchoff's law is slightly more fun than everything else in the UEC syllabus. And that's because it actually involves some pretty fun calculations. So before you do any question regarding Kirchhoff's law, or Kirchhoff's law, as I like to call it, Kirchhoff's law, you need to know what the laws are in the first place. So you got the first law and the second law. The first law is the current law, while the second law is the voltage law. So what is Kirchhoff's current law? The current law is, what was it again? The resultant force, the sum of all of the currents going in and out of a point is 0. So yeah, that is really confusing. So what do I mean by that? Okay, if you don't want to know what it exactly means, let's say you have a point here, right? Just take any point, because all of the points will give the same equation. Let's say you know that your current is going in like this. We call this I1, I2, and I3. So the way we can write it is, the sum of the currents going in is equal to the sum of the currents going out. Okay, how about another one? Let's say you have like this. So okay, this one is a bit more confusing. But okay, wait. I'm not gonna use this because this one is actually not in the thing. It'll get really confusing. But I do have this one. No, not this. Here. How about this? I1, I2, I3. Again, the sum of the currents going into a point is equal to the sum of the currents going out of the point. So in here, I1 plus I3 equals to I2. Because these two are going into it, this one's going out of it. So yeah. And normally you'll be able to find these currents because they should be able to give it to you in the question. So for example, this one. This is I1 and I2. So this whole thing is I, this whole thing is I2, and this whole thing is I1. So how do I know the equation? If I know this whole thing is I, this whole thing is I2, so it continues, right? And this one is I1 here. So I plus I1 equals to I2. Because these two are going in and it's equal to this one going out. Think of it as this is equal to these two being combined together. That's why this law exists. And the way they explain it is confusing, using like resultant current is 0 and so on. But I don't like memorizing that. I like memorizing it in the way that the sum of the currents going into a point is equal to the sum of the currents going out of a point. So yeah, that's how I will explain it. The next one will be voltage law. And voltage law is also explained in a confusing way. The way it's explained is the sum of all of the sum of the voltage in resistors and the EMF of the cells are equal to 0. But the way I would like to explain this is in a loop. Remember, I forgot to add the in a loop part, but in a loop, the sum of voltages of dry cell, the sum of what's it called again? EMFs in a cell is equal to the sum of the voltages of every resistor. So basically, the value of all of these added together is equal to the value of these added together. But remember, we're talking about loops here. So there are multiple ways to write a loop. Okay, so we have the external loop and the internal loop. So how will I determine my loop? Your loop can be any direction you want because it will give the same answer. But to make things less confusing for you, I will follow this. Current travels from the... In general, current travels from positive to negative, like this. And yeah, think of it as current travels from a high potential to a lower potential. So it will, so here is high, here is low, right? But how do I say this? Some people might get confused, and then they'll go this way. But let me just see, what is voltage? What is current, direction of current again, to be safe, because I also get confused about it sometimes. Yeah, current actually travels from negative to positive, but we say it as it travels from the positive terminal to the negative terminal. It will go the long way, so it will go like this. It will go from here. It will start at here and it will end at here, if you get what I'm saying. And then the reason why is because when it goes up back to here, it will refill. It will go through the positive terminal, and then it will gain voltage again. Then it will just keep going round and round and round. Think of this as a refill station. The negative is where you fill your gas, and the positive is where you start. So it will just keep going round and round and round like a car, so going through laps in the circuit. So yeah, that's the way I understand it. But with that in mind, since you know it goes from the positive terminal to the negative terminal the long way, I will normally make my loops go in that direction as well. So this way. When you're talking about loops, you only want to look at the loop part, not the middle part. If I'm talking about the external, okay, for example, let's say I want to talk about this loop, this first loop. Then the loop goes through here, 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 and here. So I don't have to care about these parts. But what if I want to talk about the external loop? The external loop is here, 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 here. So I don't have to care about the middle, because the loop is basically a circular direction now. So yeah, just keep in mind that when you write a loop, you only want it to go one direction. You don't want it to split out into multiple directions. So in other words, pretend it doesn't exist. Oh my god, why is my... In other words, pretend that everything else doesn't exist and only focus on your loop, and just do this and just find the sum of the voltage and the voltage of the batteries and the total voltage of the resistors. So yeah, again, sum of V is equal to sum of IR. And remember, let's say you have this, right? So you know that it will go from positive to negative, right? Positive to negative, so it will go this way, right? But how about here? Here's another positive and negative one. So would it just take a U-turn and then keep doing like this? No, it doesn't. What instead it does is, it will minus the total voltage you have right now from your current voltage. So for example, let's say here is 20, here is 15, right? If your circuit looks like this, then 20 and 15. So here's your positive, here's a negative, here's a positive, here's a negative. It will go through the 20, it will go to the negative terminal, and then remember, negative to positive is like refilling. So it will add 15. before it goes down, back down. And then 20, 15, 20, 15. So it'll add together, it'll be 35. But if it's like negative, positive, and then it goes to positive again, you minus. So yeah, you just have to keep that in mind. So for example, so this answers look very confusing, right? So I'm going to do this in my own way. Okay, so first of all, this one is correct. This one is definitely correct. Second one, let me look at the first loop first. Loop A B C D A, A B C D A. So we're talking about that loop first. So the loop goes this way. So sum of voltage 8 is equal to sum of the voltage of the resistor. So V equals to I, alright. Then you know, then here's the thing. You have to be careful because the current here and the current here are different. The current here applies to this resistor. The current here applies to this resistor. So 8 equals to 16I plus 20I1. No, not 20I1. Negative minus. Now, why minus? What's the thing? We want to add them together again. Why is it minus? That is because if you were to look at this again, the current of I is going this way. So you want to continue your current down this path, right? But your I1 is going the opposite direction. So when you're talking about opposite direction, you do minus, right? So that's why it's minus 20I, I1. Be careful about this. Remember that your loop decides the direction of your current. So if your loop goes this way, negative, this is positive, this is negative. It's still correct. It's still correct. Because if I were to go the other way, let's say I make my loop go the other way, right? Let's say I make my current loop go the other way. So it's going from negative to positive. It's going the opposite direction. So it'll be minus 8 equals to 20I1 minus 16I, which is basically the same thing. They're the same. It's just that it's easier for you to follow the battery's loop. The current of the battery. So yeah, just be careful when you're dealing with currents going in opposite directions, because they will affect your equation, the answer, a lot. If you get them wrong, if you get one of them wrong, the whole thing will mess up. So you need to be careful. You need to make sure that you got your loop direction correct. Not the correct. You need to make sure that you write your equation based on your loop direction. Okay, another one. How about the external loop? So positive to negative. So positive to negative. So that is adding. So 8 plus 6 is equal to 69 plus 5i. So 14 is equal to 16i plus 5i. 5i2, I mean. So yeah, and then after that, you just solve them using this. If you know enough basic math, I'm not gonna show you how, but yeah, that's how you get the answer in the end. But yeah, if there are 3 unknowns and you have 3 equations, so that's why you can solve the answer. I mean, that's why you can find the answer. Okay, now I think the one more thing that I need to talk about is the one that I'm very confused in. If potential at A is 0, then find the potential at B. So how do I do this? So VB is equal to VAB is equal to VB minus VA. This is the formula. The difference between 2 points is what we normally say. The difference between here and here. So how do we know what's VAB? And how do we know how do you find VA? So VA is equal to VB minus, the other way around. Okay, VB is equal to VAB plus VA. Based on this. Right, based on this. You know A is 0. So VB is equal to VAB. So how do you know what's VAB? VAB is this way, from A to B. So what do you get from A to B? How do I know the resistance from A to B? Okay, so let me just look at the question again. The metal wire has a resistance of 14. So this whole thing is 14 ohm. And then your I2 is going the same direction. And the I2 you got from here is wait. Let me just look at this again. Okay, so the IT you got from here is 0.601. And then yeah, this is where I normally get confused. Okay, I'm gonna go back to this one. VAB is equal to VB minus VA. So VB is equal to VAB plus VA, and VA is 0. So VB is equal to VAB. So VB here is actually negative 9.86 volt. But how do I get 9.86 volt when I have everything as positive? Okay, how will I explain this? Oh, okay. I guess one way for me to explain it is remember that this is resistance. What do I mean by that? Remember back to Kirchoff's law. When the reason why Kirchoff's law is a thing is because when you go through a resistor, your voltage drops. Your resistor uses up voltage. So how will I explain this? Okay, VAB is equal to yeah, how am I gonna explain this properly? I mean I myself get it, but okay. I'm just gonna mention one thing. Okay. When you go through a resistor, your voltage drops. Right. It's very confusing because you have to know when to minus, when to plus. But the way I understand is if it's minus, if it's going through a resistor, it's minus. If it's going through a battery, it's plus. But only if it's going through the positive terminal first. Yeah, only if it's going through the negative terminal first, sorry. Because remember, when you go through negative to positive, it recharges, it refills. I just call it refill, but it's not refilling, it's just recharging. So there is a gain in potential difference. Here is low potential, here is high potential. So you have a gain in potential difference. But when you go through a resistor, the resistor uses up some of the voltage for itself. So it has a drop in potential difference. So that's why we have this formula. Sigma sum of voltage is equal to sum of IR. Sum of voltage of batteries or EMFs is equal to sum of the voltage of resistance. Because if you were to add these two together, you get 0. That is the original point of Kirchoff's law. That is what we got from here. It's just that I prefer using this one because it's less confusing. But but even with that, you still need to get your fundamentals, which is if your current goes through a resistor, there is a drop in voltage. When there is a drop in voltage, you have a negative voltage. Your voltage is negative. So yeah, I guess that's all. Wait. Yeah. So I guess that's how you get negative. Now, how about finding AB? So you have to again remember, I1 and I2 are completely different. I1 and I2 are completely different. This is halfway. So if you have a total resistance of 14 and they are evenly spread, then you know that halfway is 7 and 7 now. Then you just multiply them with their what the respective currents. But remember, since it's resistance, it's minus. I guess that's why I've been getting it all wrong recently. Let me just find another one that I can try my things on. This one. X and Y. So how do I find X and Y? So Vxy is equal to Vy minus Vx. Right. Vx is 0, so it's equal to Vy. So Vy is equal to Vxy. So how do I find Vxy? Vxy is this direction. So when you go this direction, remember that again, refilling and dropping energy. Since it's going from positive to negative, it experiences a drop in energy, a drop in voltage. So minus. So your answer at the end is minus 12. Again, it's very confusing because it says that current travels from a positive terminal to a negative terminal. But when you have the current force itself through the terminals, if it goes if it takes the shortcut, we normally say that the current starts from the positive terminal, but it ends at a negative terminal. But the truth is that when the current travels from positive to negative, it experiences a drop in voltage. And it will that's why in a circuit, when it goes through a resistor, it will also experience a drop in voltage. So it will go down, 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 and then go back up, go down, 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 go back up. So I would maybe need you guys to change your mindset a bit. Current travels from positive terminal to negative terminal. But there is a gain in potential difference, in electric potential, if it were to start from negative, if it were to go through negative to positive directly in the same cell. And if it go the other way, it will be negative. So yeah, I guess that's how I can explain it to you. If first of all, write down first, Vxy is equal to Vy minus Vx. Next, you have to determine what the currents are. In this case, you have if they are resistors, you have to determine the current. If they are batteries, you don't have to care. But yeah, if they are resistors, just remember that a resistor uses voltage, so the voltage will drop. So you have to minus. And if the current goes through the wrong way of the cell, then it will also drop in voltage. But if it were to go through the negative one first and then the positive, then it will increase. So I guess that's all. Again, I'm sorry if it's not clear enough.